is the meaning of square? It can be expressed as a product of number with itself. So, square is expressed as a product of a number with itself. That is, if we consider 1 square, then 1 square can be expressed as 1 multiplied by 1. In a similar way, 2 square, that is equal to 4. So, 2 square can be expressed as 2 multiplied by 2. So, 2 into 2 is 2 square. So, it is this is a square of a number 2. Now, we can understand it geometrically also. Let us consider a square. So, in this figure, A, B, C, D, let us suppose its length is A. So, side of the square is A. Now, area of this square can be expressed as side multiplied by side. That is side square. So, we can express it as a side square. Now, we will do the properties of the square. Now, let's do properties of the square. Our first property is, if a number has 1 or 9 at a unit place, then square of that number will also end with 1. That is, if we consider 9 square, that is 9 into 9, that will be equal to 81. So, in this, at a unit place, 9 is present. But when we square this number, that is when we multiply this number with itself, we get 81. So, here at a unit place, 1 is present. So, our property is also that explain, if a number has 1 or 9 at a unit place, then square of that number will be end with 1. In a similar way, if we consider 21 into 21, so by multiplying this, we get the product 441. So in this, when 21 is multiplied by itself, we get 441. Here unit place is 1. So when we multiply this number with itself, we get the product 441, in which this number is end with 1. That is, it at its unit place 1 is present. Now second property is कि अगर हमारे पास कोई ऐसा नंबर है जिसका यूनिट प्लेस पे 4 या 6 प्रेजेंट है, तो उस नंबर का जब हम स्केयर करेंगे तो वो नंबर 6 नंबर के साथ एंड होगा. दैट इज उसके यूनिट प्लेस पे 6 प्रेजेंट होगा. नाउ लेट्स कंसीडर सेकेंड एग्जांपल, दैट इज 4 मल्टीप्लाइड बाय 4. दिस इज इक्वल टू 16. So we have a number that is 4. So here at a unit place we have 4. So when this number is multiplied by itself, we get 16 as a product. Now in this number at a unit place we have 6. So this properties also explain the same, that if a number has 4 or 6 at a unit place, अगर किसी नंबर के पास यूनिट प्लेस पे 4 या 6 नंबर प्रेजेंट है, तो जब हम उस नंबर का स्केयर करेंगे तो उस नंबर के यूनिट प्लेस पे भी 6 ही प्रेजेंट होगा. तो अगर हम इस एग्जांपल को देखें तो इसमें जब हम 4 नंबर को 4 के साथ मल्टीप्लाई करते हैं तो हमारे पास 4 का स्केयर दैट इज 16 आ जाता है. तो इसके यूनिट प्लेस पे 6 प्रेजेंट होगा. इन अ सिमिलर वे, if we consider 6 multiplied by 6, we get 36. So in this unit place is 6, but when we taking the square of this number, we get 36. So here in 36, unit place is 6. So hence, which explain our second property. Third property is मतलब अगर किसी नंबर में ऑड नंबर ऑफ जीरोस प्रेजेंट हैं तो जब हम उस नंबर का स्क्वायर करेंगे तो उस नंबर में उस स्क्वायर में इवन नंबर ऑफ जीरोस प्रेजेंट होंगे. लेट अस कंसीडर इट विद एग्जांपल. सपोज वी हैव अ नंबर 10. तो इस 10 में हमारे पास सिर्फ एक ही जीरो प्रेजेंट है व्हिच इज एन ऑड नंबर. नाउ व्हेन वी टेकिंग द स्क्वायर ऑफ दिस नंबर वी गेट our product 100. So here only one zero is present, but after squaring this number we get 2 zero which is even number. In a similar process, if we consider 1000, then 1000 square that will be equal to this. So here even number of zeros are present, but in this case odd number of zero are present, but when we squaring this number we get even number of zeros. So this explains the three properties of the square. Now let's consider our fourth property. A sum of consecutive natural number is equal to the perfect square. A sum of consecutive natural number is equal to the perfect square. Now let us consider an example. So if we consider 3 square which is equal to 9. Now 9 can be represented like 4 plus 5 equal to 9. So here 4 and 5 are the consecutive natural number. So this property also explains the same thing, that is sum of the consecutive natural number. So here 4 and 5 are the consecutive natural number. Consecutive natural numbers are the numbers which are taking one more than the previous one. That is, if we consider 4 as a natural number, then its consecutive number will be 5 and consecutive number 5 will be 6. Consecutive number of 3 will be 4. So one more than the previous one. So these are the consecutive numbers. So here we express 9 as 4 plus 5. So this property also explains the same thing, that a sum of the consecutive natural number is equal to the perfect square. That is, अगर हम किसी भी दो consecutive natural number का sum करेंगे तो इसको हम perfect square के equal लिख सकते हैं. तो यहाँ पे 4 plus 5 9 के equal है. 9 को हम कैसे लिख सकते हैं? 3 square which is a perfect square. In a similar way, if we consider 25, then 25 can be expressed as 12 plus 13. 12 plus 13 are the two consecutive natural number, and this can be written as a sum of 25. Now again 25 can be expressed as 5 square. That is 5 square is equal to 25. So this is a perfect square which can be expressed as sum of two consecutive numbers. Now our question is that if we are giving a perfect square, that is 5 square, then how can we write it into the sum of two consecutive numbers? That is, we have to find the two consecutive natural number. We are given only a perfect square. Now for this we will use a formula, that is perfect square. Let it be denoted as x square. So we have x square minus 1 upon 2, and second number will be found by the formula x square plus 1 upon 2. So here our x is 5. So we will have 5 square minus 1 upon 2. That is 5 square is 25. So 25 minus 1 upon 2 is 24 upon 2. That will be equal to 12. Now second number is x square plus 1 upon 2. So x square will be 5 square plus 1 upon 2. That is 25 plus 1, 26. 26 upon 2. That is equal to 13. So our number are 12 and 13. So sum of these two consecutive natural number can be expressed as a perfect square. So this explains our fourth property. Now let's do our fifth property, that is product of two consecutive even or odd natural number is equal to 1 less than the perfect square. I repeat, product of two consecutive even or odd natural number is equal to 1 less than the perfect square. Now let's see. For this we will consider an example. If we consider 11 and 13, these are two odd natural numbers. Now we will take the product of these numbers. Then 11 multiplied by 13 is 143. If we multiply these two numbers, we get the product 143. So here 143 can be expressed as 12 square minus 1. That is 143 equal to 144 minus 1. So here 144 can be expressed as 12 square minus 1. So this is a perfect square minus 1. So which explain our property, that is product of two consecutive even or odd number is equal to 1 less than the perfect square. So here 11 and 13 are odd number. When we get the product of this number, we get 143, which is equal to, which can be written as 144 minus 1, and 144 can be written like 12 square, which is a perfect square, and minus 1. So it can be explained this property. Now we can consider one more example, that 13 multiplied by 15. Once again, this is also, these are two odd numbers. Now if we get the product of these numbers, we can multiply it. We get 195. So here, if we consider another example, 13 multiplied by 15, which equal to 195. Now 195 can be written like 196 minus 1, which is our 14 square. So 196 can be written like 14 square minus 1. So 14 square is again a perfect square. So perfect square minus 1. So in these two examples, we can generate a formula, that is a minus 1 into a plus 1, that is equal to a square minus 1. If we look at this identity carefully, then we can remember an identity of algebra, that was a minus b into a plus b equal to a square minus b square. So here our a and b is 1. So a minus b into a plus b equal to a square minus b square. So here b square is 1. 1 square is equal to 1. So we can write simply a square minus 1. So in this way we can explain our property. Now let us consider one more question. How many non-perfect square numbers lies between two consecutive perfect square? I repeat, how many non-perfect square number lies between two consecutive perfect square number? Now let us consider an example. If we consider 1 square and 2 square, these are the two perfect square number which are consecutive. So 1 square is 1 and 2 square is 4. So between 1 and 4 the number lies that are non-perfect are 2 and 3. Now again we consider one more example, that is 2 square and 3 square. These are also two consecutive perfect square number, that is after squaring we get 4 and 9 respectively. So the numbers which are lying between these two perfect square are 5, 6, 7 and 8. These are the four numbers which are not a perfect square and lying between the two consecutive perfect square number. Now in the similar way we can find lot of perfect non-perfect square number which are lying between the two consecutive perfect square number. Now if we are solving this by simply considering the examples, but if we consider a large number, then how can we find the number which are not a perfect square? For that, let us consider a case. So here n and n plus 1 are the two consecutive natural numbers. So squaring these two numbers, we get n square and n square. So n plus 1 square and n square. Now subtracting the square of these two numbers. So we get a plus b whole square is a square plus b square plus 2ab minus n square. After solving, we get 2n plus 1. So this is a difference of the two perfect square number, that is 2n plus 1. So if we want to find the non-perfect number between the two consecutive square natural number, then that will be equal to 2n, which is 1 less than their difference. So if we calculate this again by this general method, so here 1 and 2 are, so our 2 is n plus 1 and 1 is our n. So by putting this over here, that is 2 square minus 1 square, which is equal to 4 minus 1, that is 3. So 3 is a difference between the two consecutive perfect square, that is 1 less than the difference, which is 2. So here two numbers are present which are non-perfect square between the two consecutive perfect square. So these are 1 and 4, so 2 and 3. So two numbers are lying between the two perfect square. So by this general formula, we can find any non-perfect square number between the two consecutive perfect square number. That's all. Let's do one more question. That is, if 32 can be expressed as a perfect square. So for that, we will check firstly whether it is lies between two consecutive perfect square numbers. So 32 number is less than number that is 25, which is a perfect square. Now again 32 is greater than 25 and less than 36, which is also a perfect square. So that is, we can write it as 32 less than 6 square. Now here, so 32 is a number which is lying between the two consecutive perfect square. We have already proved a result that if a number is lies between the two consecutive perfect square, then that number will never be a perfect square. So 32 cannot be written as a perfect square. So 32 is not a perfect square. I repeat that if this number is lies between two consecutive perfect square number, then that number is not a perfect square. Since 32 is lies between 25 and 36, and 25 is a number which is a perfect square of 5 square, and 36 is a number which is a square of 6, that is 5 square and 6 square. So 32 is lies between 5 square and 6 square. So 32 is not a perfect square because it is lies between two consecutive natural square numbers. Now next is sum of odd natural numbers are represented as n square. So we have odd natural numbers. Now our first odd natural number is 1. So that can be represented as 1 square. Now secondly, we have another number are 1 and 3. So sum of these two numbers can be 1 plus 3. So 1 plus 3 is 4, which can be written as 2 square. Now next is 1, 3, 5. So 1 plus 3 plus 5. So sum of 1 plus 3 plus 5 will be equal to 9, which can be written as 3 square. In a similar way, 1 plus 3 plus 5 plus next number will be 7. So that will be equal to 12 plus 3, 15 plus 1, 16, which is written as 4 square. So in a similar way, we can write 1 plus 3 plus 5 plus 7 up to so on 2n plus 1, which is equal to n square. So in this way, we can represent sum of odd natural number as n square. Now we will find some methods. So to find the square of any number, we will do some methods. So our first number is, if we want to find find the square of a number 52. So 52 square. So it is very difficult to find the square of any two-digit number. If the number is, especially if the number is large. Similarly, if we want to find the square of 62 and 72 square and so many. So if we want to find that one square, then it is simply 1. If we want to find 2 square, it will be 4. 3 square, it will be 9. 4 square, 16. 5 square, 25. 6 square, 36. 7 square, 49. 8 square will be 64. 9 square will be 81. 10 square will be 100. So in a similar way, 11 square 121, 12 square 144, 13 square 169, and so on. So we can find these numbers square very easily. But if we want to find the square of 52, then how will we find? Let us consider the identities of algebra, that are a plus b whole square, that is equal to a square plus b square plus 2ab, and a minus b whole square, that was a square plus b square minus 2ab, or simply a square minus b square, that was a minus b into a plus b. Now, if we want to find the square of this number, then this can be written like 50 plus 2 square, that is 52 square. So by using this identity, we can find the value of square of 52, that is 50 square plus 2 square plus 2 into 50 into 2, that is 100. So that will be equal to 50 square is 2500 plus 4 plus 200, that is 2704. So we can find the square of this number by using the identity of algebra. In a similar way, 62 square, that can be written like 70 minus 8 square. 70 minus 8 whole square. 70 minus 8 will be 62. So by using this identity, that is 70 square plus 8 square minus 2 into 70 into 8. So that will be 4900 plus 64 minus 56 into 2, 112. 10 is here. So by solving here, 4900 plus 64, that will be 4964 minus 1120, that will be 4483. So our answer will be 3844. So in this way, by using the identities of algebra, we can find the square of any large number. Now let us consider numbers 3, 4 and 5. Now 3, 4, 5 can be expressed as 3 square plus 4 square, that will be equal to 9 plus 16, which will be equal to 25. Now 25 can be expressed as 5 square. That means 3 square plus 4 square will be equal to 5 square. So when these numbers are expressed as this, then this is called Pythagoras triplet. Pythagorean triplet. Now here 3, 4 and 5 are the Pythagorean triplet. Now these numbers are so simple that we can calculate it with a very similar way. But instead of these numbers, we are given only one number, that is, if we suppose a number 8. If we consider a number 8, So we are given a question that if we consider a smallest number is 8, then what are the two more numbers of the Pythagoras triplet? Then how will we find those two numbers? So we are given 8 is the one smallest number among these three numbers. So here we will equate it by equal to 2m. So 2m equal to 8. So m will be equal to 8 by 2, which is equal to 4. So m will be equal to 4. And next is m square minus 1. That will be equal to 4 square minus 1, which is 16 minus 1, 15. And next is m square plus 1. That will be equal to 4 square plus 1, which is equal to 17. So here 4, 15, 8. So 8, 15 and 17 are the three Pythagorean triplet. By using this formula, we can calculate any three Pythagorean triplet if we know one of the three number. Then we can find the next two number also. Pythagorean numbers are 2m, m square minus 1 and m square plus 1. This is basically derived from the Pythagoras theorem. That was, if we consider a right angle triangle AOB, then if this is our smallest number and this is our largest number, then 2m square plus m square minus 1 whole square, that will be equal to 4m square plus a minus b whole square will be a square plus b square minus 2m square, which will be equal to 4m square minus 2m square is 2m square. So 2m square plus m raised to power 4 plus 1, which will be equal to m square plus 1 plus 2m square. That will be equal to m square plus 1 whole square. So if we remember Pythagoras theorem result, that was h square equal to p square plus b square. So when we correlate these two results, then this is our h square, this is our b square and this is our p square. So by this we can find the any three Pythagorean triplets. Now we will understand the meaning of square root. So if we consider number 2, now square of 2 will be 4. In a similar way, consider a number 4, then square of 4 will be 16. So here square of 2 is 4 and square root of 4 will be 2. In a similar way, square of 4 is 16 and square root of 16 will be 4. So now symbol of square root. Symbol of square root, it is denoted as under root. That is, if we want to find the square root of 16, then under root of 16 will be equal to 4. Now, how we are able to calculate the value of under root 16, that is equal to 4. So for this we had methods. So method to find the square root. So our first method is repeating subtraction method. Repeated subtraction method. So in this, if we consider a number 100, so we want to find the square root of 100. So here, if we consider the repeated subtractions of odd number, so here odd numbers are 1, 3, 5, 7, 9 and so on. So we will subtract these numbers subsequently. 100 minus 1 will be 99. Now 99 minus next number will be 3. So 99 minus 3 will be 96. 96 minus next number will be 5. That will be 91. Now 91 minus next is 7. So that will be 84. Now 84 minus next number will be 9. So that will be 575. Now 75 minus 11, that will be 64. 64 minus 13, that will be 51. 51 minus next number will be 15, that will be 36. Now 36 minus 17, 19. Now 19 minus next number will be 19, that is 0. So we get at the end point 0. Now how many steps are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here are 10 number of steps. So under root of 100 will be equal to 10, because in this we will just calculating the number of steps by which we get the end point is 0, and the number of steps will be the under root of our given question. That is, here we want to find the under root of 100. So we get the 0 by proceeding 10 steps. So the answer will be 10. So in this method we use odd numbers. So by subtracting the odd number from the given number, we will get 10 steps, and by using these 10 steps we will find the under root of 100. Now our second method is prime factorization. Prime factorization. So let us consider a number 625. So prime factorization of 625 is, so here 5 on the 5, 5 to the 10, 2 is 25, 5 by the 25. Now 5 to the 10, 2 is here, 5 by the 25. Now 5 by the 25, 5 on the 5. So it is 5 multiplied by 5 multiplied by 5 multiplied by 5. So we will take the couplet of the numbers, that is 5 multiplied by 5, which is equal to 25. So hence square root of 625 will be 25. So in a similar way we can find any square root of any number by the prime factorization method. So our next method is long division. So let's solve the square root of 625 with long division method. So here we will take the pair of the number from the right hand side to left hand side. So 25, here is only one number present, so single number. So we will move 6. So for this हमने वो नंबर चूज करना है जिसका स्क्वायर इससे छोटा हो या इसके इक्वल हो. So here number is 6. So in this case we choose that number whose square is either equal to 6 or less than 6. So here 2 square is 4, 3 square is 9, which is greater than 6. So we will choose 2. 2 square, so 2 2s are 4. 6 minus 4 will be 2. Now a pair of 2 numbers will be taken down. So 225. 2 multiplied by 2 will be 4. So 4. जो हमें ऐसे नंबर चूज करना है कि 41 को हमने 1 के साथ मल्टीप्लाई करा तो हमारे पास 41 आता है. In a similar way 42 2s are, जो नंबर हमने यहाँ पे पिक किया वही नंबर हम नीचे लेंगे. तो 42 into 2 that will be 84. So in a similar way here number is 5. So instead of taking all the numbers subsequently we will multiply it with 5. 5 5 the 25. 4 5 the 20. 20 plus 2 22. So 45 by the 225. So square root of 625 will be equal to 25. So in this way we can find the square root of any number.